Okay, so in the previous video, we discussed about how we could be using ML to predict mechanical seal failure in a dry gas seal system and implement the appropriate countermeasures. So this time around, what we're going to see is you can see my previous video for how this system was proposed to be designed. But in this video, what we'll do is we'll look at how the user experience for this product is to be designed. So for user related considerations, there are primarily four considerations: the input output, the transparency, the uncertainty of the output, and the feedback loops. So the input output is pretty clear that it is going to be through a sensor network or a existing network of transmitters that the user already has. So since these systems are governed by bodies like the API, there are standard methodologies to how to predict failures or how the flow or pressure should be in case of an alarm for high case, high case, or low flow cases or low pressure cases. So there is pretty much a lot of transparency that will be when designing the model and the algorithm. So this will be informed to the user, ensuring that there is transparency. So the user can figure out why the output is the way it is. For uncertainty in the output will be taken in terms of percentage value to show how close the current operational state is close to the normal state and how far it is from an extreme case of failure. So this means that we'll be giving a probabilistic output rather than a deterministic pinpoint output. For the feedback loops, as a standard practice, for predictions, when there are major predictions of failures or warnings given by the tool, the user will be prompted to give in feedback to see whether the prediction was right or not. And if it was not right, then what is the feedback that the user has? Or if it was right, then what feedback the user has to make it even more better. So these are the considerations that we need to take care of. Uh, Related to ethics and privacy, so there is a lot of data, and all of this data comes with a lot of privacy considerations. So for privacy, this model will obviously be trained on data given by the user itself from already operational systems. So this means that the data stays safe and the model gets trained on the application that it is expected to support. So this data is restricted to the user itself and catered for the purpose or for a particular client and not universal. As far as privacy laws are concerned, the laws of where the tool is being developed, the area where it is intended to be used, and the legislative laws of both the organization, the developing organization and the client organization are to be considered. So while developing or while deploying this tool, all the parties in the picture will be made aware of the set of laws and regulations that the tool is subjected to and what part of these do or do not apply to the tool. In terms of the ethical consideration, we'll see how the AI performs in terms of fairness, accountability, and transparency. So, talking of fairness, the data we are using is supplied by the user itself. So, it will be modeled to the standard methodologies. And due to this, the AI is designed to react in a similar way to similar way to similar inputs. So that ensures fairness for most of the cases. Accountability, since it is based on standard methods, it is very much accountable to the output prediction. Also, when the tool is designed to give a prediction or an alarm, but the final decision stays in the hands of the user who is using it or human. So it allows for recourse for the user. Transparency. So for transparency, the user will be familiarized with how the model is reaching the output. And this will make the operation not only more interpretable, but also it will help the user to maybe even debug problems or figure out solutions to some nitty-gritties that come along the way. There are a few sources for biases that we could look at. So there is a learning bias that can be observed. So the system is being trained on existing system data and some old system data. So this will lead to the model being trained for situations that the user has probably already faced and not for the situations that the user has never encountered. So the model will learn to react to situations that the user has already faced and the operational conditions that the user already has or have previously used. So for those cases, the model will be very much biased to these situations. But for situations wherein the normal data is close to the alarm data for the old conditions, for those cases, the prediction might be wrong. So that is one thing. Then we could observe a deployment bias. So the model is being deployed on real world systems which are dynamically changing, but this tool is being trained on system data which was isolated and devoid of any dynamic changes. So the system might struggle a little bit in dynamically changing user environment because it is unable to adapt to dynamic changes based on the training that is undergone. For feedback loop bias, we know that feedback is user dependent. So since it is user dependent, this feedback will really change from user to user. So similar situations will have different feedbacks from different users, leading to the model being updated with different feedbacks for the same situation, leading the model to have a database of outputs or the database of signals wherein the model will be reacting in a very unpredictable or different way based on the starkly different feedbacks that it is getting based on individual understanding. So these were some privacy ethical considerations that need to be taken care of and looked into while developing this kind of AI tool.